Welcome to Sairam Tripoli YouTube channel. Let us discuss model 2 generation of AC voltage. Already we discussed the DC voltage. In the previous class we discussed. I'll show you the this one. In the previous class we discussed cascading of transformer. So one unit is the in 1 unit output is the input of another unit. Second unit output is the input of third unit. Finally, you will get 3 times of voltage because depends upon number of units, right? See here T1, T2, T3 are the cascading transformer units, and IS1, IS2, IS3 is the isolating transformer units, and C1, C2, C3 capacitance of voltage divider, high voltage measurement after first, second, third stages, and V1, V2, V3 for a metering after first, second, third stages, and the primary LV winding and secondary HV winding, and third is excitation winding. See this part, okay, this part is primary winding and this part is secondary winding and this part is excitation winding for the excitation purpose, right? The rating of primary are low voltage windings, usually 230 volts to 400 volts input, okay, 230 to 400 volts, and small unit up to 100 kilovolt ampere. For a larger output, the voltage rating low voltage winding may be 3.3 kilovolts, 6.6 kilovolts, or 11 kilovolts. So this is supply. This is supply, okay. And if you give output as this one is V2, here this part V2, this one is 2 times of V2, this one is 3 times of V2. See, already we discussed this is 1 unit, okay, and another unit is this one. See, third unit is this one. So internal circuit diagram, this one. Basically, this is one part, this is second part, this is the third part, right? So this is a grounding of all the units. See here, grounding of all the units, right? So already I told you the first unit output is the input of second unit. So second unit output is the input of first unit, input of third unit. So finally you will get 3 times of V2. See V1, V2, I mean like 3 times of 3, 1, 2, 3. 3 times of V2 will get, and supply voltage is V1, and if suppose voltage we are giving 230 we'll get 100 kilovolt ampere, 100 times of voltage, kilovolts, right? Sorry, 1 minute. Okay, so let's move on to the next slide, that is explanation. Supply to the units can be obtained from power generators that are through induction regulators, variation up to voltage, and isolated transformer IS1, IS2, IS3. So 1:1 ratio transformer. So isolated transformer we are using. There are insulating to their respective tank potential and are meant for supplying the excitation for the second and third stages at their tank potential. Power supply to the isolating transformer is also fed from the AC input. So the advantages of cascading connection, natural cooling is sufficient. Already we know, right? So natural cooling in the sense air forced, air natural cooling, or likewise, and water forced, water natural cooling, like normal cooling. Transformers are light and compact. So transformer, whatever you're using is a small type of transformer, small compact size transformer. So that's light in weight and compact size, and easy age of transportation and assembly. So see, if it is the large transformer we cannot carry, right? Very difficult to carry the transformer, but the transportation is very easy because a single transformer, I mean less weightageable transformers we are using, and construction is similar to the isolating transformer cascading unit. Either star or delta connection are possible. So star and or delta connection is possible in this transformers. And drawbacks, more space required and expensive. So number of transformers if you connect, what happens? So it requires more space, right? If it is only small unit will be there, means okay, only 1 unit you can place, but the unit is more, I mean like number of units are more, so the space requirement very more. And next we have a resonant circuit. A resonant circuit is also you can call it as a tank circuit. So either maybe having a RC circuit or RL circuit. Here there is a LC circuit will be there. L is the inductance, C is the capacitance, and across the voltages R. Right. Resonant principle of the series tuned RL LC circuits can be made use of obtain higher voltage with a given transformers. Uh, the basic principle of resonant circuit already we all know, right? Already we derived the equations also in the basic electrical or some other like electric circuit analysis. The resonant principle series tuned LC circuits can be made use of obtain higher voltage and given transformer. Let R represent the equivalent parallel, sorry, resistance across the coil and the device under test. The current I would be given by I is equal to what? V by R, right? So we are, see here, this is 1 by j omega c. This this part is 1 by j omega c, and this part these two parts are series parallel connection. So R1 into R2 divided by R1 plus R2. That is omega j omega L into R divided by j omega L plus R. So this is a parallel. This one is parallel connection. This one is series connection. Just to put the loop equation over here. So you get V is equal to what? I into R equivalent. So R equivalent is this one. Just to take this one. If it is this one. Output voltage, okay, this is output voltage, not R equivalent, I mean this R equivalent, okay. J omega L R by R plus j omega L. So finally we will get V is equal to omega square LCR into E divided by R plus j R and j omega L. Just you substitute the values here. This part you substitute here, I part, okay. This part I think we got right. This I is equal to, I'll take A, this one, this is B. So V by A plus B, where B is equal to what? These two are in parallel. Finally, V is equal to what? I into R, output voltage, okay. This is output voltage. I is this one. Just to substitute over here, we will get this equation. After simplifying, we will get the equation like this. Since R is usually very large, the Q factor of the circuit is R by L omega. Q factor for Q factor is R by L omega or omega L by R would be very large. The output voltage would be given by V is equal to E into R divided by L omega E into Q. It can thus be seen that a much larger value of input can be obtained across the device under test in the resonant principle. At resonance, omega is equal to what? 2 pi f, right? 1 by root LC. Okay. Okay, resonant transformer in an electrical components which consist of two high Q coils, LC coil, wound on the same core, the capacitor connected across the winding to make a two coupled LC circuit. So capacitor is connected to make a two coupled LC circuits. A resonant transformer, when is exactly resonance occurs, XL is equal to XC, resonance phenomena. High voltage generation which operates on a resonance phenomena, XL is equal to XC. In the resonance condition, the current through test objects is very large and that is limited only by the resistance of the circuit. The waveform of the voltage across the test object will be purely sinusoidal. So application of resonant transformer, this principle is utilized in the testing at very high voltages and on occasions required large current outputs such as cable testing, dielectric classes, measurement particle discharge, measurement etc. So next class we'll discuss in the next class we'll discuss series resonant circuit and parallel resonant circuit. Series resonant circuit, LC is series and the equivalent circuit I think same as a transformer, and parallel circuit it connected to parallel one. So in the next class we'll discuss in detail. I think resonant circuit you understood, right? So the how we got the equations and all. So similarly we'll go through series resonant circuit.